Hello everyone, welcome to the video of vibration analysis of rectangular plate. Problem statement of this video is to find first 6 natural frequencies and mode shapes of the uniform curve of rectangular plate with simply supported edges undergoing transverse vibration using ANSYS. So these are the dimensions of the plate as shown in the figure. These are the properties of the material. Okay, let's get started with ANSYS. Okay, ANSYS has been opened. Now from analysis systems, go to model option and just drag and drop here in project schematic. Now right click on engineering data and click on edit. Now if there is no material available here, so suppose this is blank, then go to engineering data sources and click on this plus button right in front of structural steel. Then again go back to engineering data sources. The material will be visible. Now I'll change the name of the material to my material to avoid any confusion in future. Now I will assign the properties with 3700 material density. Young's modulus is 140 GPa and Poisson's ratio is 0.33 as mentioned in the problem statement. Now our material has been assigned. Close the tab. And the next is go to geometry, right click on it. Now select whatever option suitable for you out of these three. I'm going to select new design modeler. Okay, now right click on XY plane and click on look at. Go to units and select millimeters. Now click on new sketch, click on sketch, go to sketching, click on rectangle and draw one rectangle. Go to dimensions and give dimensions to the rectangle. Horizontal dimension is 2000 mm, that is 2 meter, and vertical dimension is 1000 mm, that is 1 meter. So this is our plate. Now go to concept and click on surface from sketches. Now select the sketch and click on apply. Now the thickness of our plate is 10 mm. So write 10 here and click on generate. So our model has been created. So close the design modeler. Now right click on model and click on edit. Okay. Now our next aim is to assign material to this geometry. So go to geometry, click on surface body, scroll below, go to assignment, click on this arrow and select my material. So the material has been assigned. Now go to mesh. Now here default element sizes like this, we are going to change it and we will make little smaller element and click on generate. Okay, so meshing has been done. Now right click on model, click on insert and click on simply supported. Now go to edge select option, press Ctrl button and select all 4 edges and click on apply. So now our 4 edges are now simply supported. Next go to analysis settings. Since we are going to find out first 6 natural frequencies, but by default let us find out first 30 natural frequencies, because sometimes those few of the natural frequencies gets repeated. Now click on solve. Okay, it is done. Now click on the solution. So these are our 30 modes. Now to get more shapes, just select all the modes which you want, right click on it and click on create mode shape results. Now again click on solve. Okay, now mode shape results has been generated. If you click on first total deformation option and just click on play, you can see this is the first mode. If you click on second and click on play, this is the second mode. If you click on third and click on play, this is the third mode. If you click on fourth, this is fourth mode. If you click on fifth, click on play, this is fifth mode. If you click on sixth, this is sixth mode. If you click on 7, if you click play, this is 7th mode. Okay, let's take screenshot of all these frequencies. Okay, let's go to PPT. Okay, these are the analytical results, and if I try to compare them with the ANSYS results, then we can clearly see that first result is 37, here it is 36.9, second one is matching, third one is matching, fourth one is matching, fifth one is matching, sixth one is matching, and seventh one is also matching. And please note that omega 22 and omega 41 have the same frequency, so these are degenerate modes. That's it for today, guys. Thank you for listening.